today's webinar. The topic of our today webinar is a role of transfer learning in AI and ML. So we can see that artificial intelligence and machine learning is a really trending topic in the computer science and engineering field. So this webinar is organized by the Pharma Institute of Technology CSA department. So Dr. Praveen Gupta is the speaker of our today's webinar. So welcome, Dr. Praveen Gupta. Welcome to the Parul University. And I'll just give you the little introduction about the Dr. Praveen Gupta. So Dr. Praveen is the assistant professor in computer science and engineering department into the Geetam University, Vishakhapatnam. So welcome.
Thank you. Thank you. Yes. Can I start?
So you can start.
Yes. There is some background sound coming. Some background sound is coming.
Yes, sir.
There is loudspeakers type something. Yeah. Okay. Okay. Yes. So thank you for inviting me. I am Dr. Praveen Gupta, working as assistant professor, Department of Computer Science and Engineering, Geetam deemed to be University at Vishakhapatnam. So before starting, I tell you myself in briefly. I have approximate 25 years of experience in the teaching and software companies. 8 to 9 years I have worked in various companies with various positions up to the project manager. And in the teaching field, I have worked across all the positions and now working with the Geetam University. So today's topic is the role of transfer learning in AI and machine learning. So for the new engineers, I would like to discuss some of the points, how the technical changes, how the programming changes are coming in the field of computer industry right now. So now we try what is an artificial intelligence. So humans are the most intelligent persons among all the species since the mankind. And in the last thousands of years, we are trying to understand how we think, how human think, how we see, how we perceive, understand, predict, and manipulate the world for longer and more complicated things. So human is trying to see how a human mind works, perceives, understands, and predicts the things. The artificial intelligence is now an effort to replicate the human mind in the form of the programming field. So what we are doing in the field of AI, we are trying to understand. Since a long time, programming is there, but now since last few years, AI is now upcoming phase. The foundation of AI is as follows. First, we more general follow the law of thought approach because correct inference is just one of the several approach mechanism for achieving rationality. So we have to think what law of thought, how we think. Second, foundation of AI is scientific development, then an approach based on human behavior and human thoughts. So now we are linking programming with the approach that's scientifically thinking how the human is thinking. We are now trying to do that one. So let us try to understand how a human mind thinks. This diagram, we are able to see a neurons, a smallest cell of a human mind. It has some axons, synapses, and it is showing a little bit understandable architecture, what is the smallest part in a human mind itself and how it works. So even though medical science is not up to 100% guarantee how it actually works, but it is something like that one. You can assume it works like this. So we are trying to identify what is the capability of a human mind and how it works. Somebody try to compare it with the supercomputers, personal computers, and human brain. If we compare it with all these parameters, you will find that a human brain is having a very good capacity in all respects. So we have tried to compare it with the number of computation units. In computers, we have transistors. In human brain, we are having neurons. Storage unit, how much we can store. computers are having RAM 10 to the power 14, 10 to the power 11 RAM, but human mind is having neurons. Similarly, processing time, cycle time, super computers 10 to the power minus second, personal computers 9 to 9 seconds, then human mind 10 to the minus 3 seconds. So you can see that it is a comparable. And then operation cycles 10 to the power 15 operation by supercomputer, but human brain is 10 to the power 17. Means human brain is still more capable than your a supercomputer. Then you compare memory updates. Some computer is doing 10 to the power 14 and human brain is also doing 10 to the power 14. Means figures are somewhere higher on the human brain's capability, except on the few points. So now what a programming perspective is coming these days, we are trying to do programming as our human mind is thinking. So these are the some of the areas of the AI. This include economics, philosophy, computer science, psychology, neuron science, linguistics, maths. So computer science related to us, computer science, economics related to financial aspects, and other are related to the human aspects. Neuron is related with the medical science aspects. So AI is the combination of all these things, all are included there. Let us look slightly history of AI. AI is not very new, means you cannot say just developed in last 5 years, 10 years. Since 1940s, 50s, starting work have been done, but the technologies were limited, knowledge were limited in the field of programming. So the focus area was somewhere else. But in the 90s and later on, the focus shifted to the neurons, and in 1986, focus shifted to the neurons, and it forced a new energy in this field, and it started getting popularity in the field of this one. Earlier to that, before 2000 and before that, when we talk about the technologies were not enough developed so that it can be applied as we are thinking. So, but in the present scenario, we are developing new programming skills, new technologies, which are in the field of AI, and they are relatively trying to capture how a human thinks. So these are the some of the applications where AI applications are found, or you can apply as a new student, coming engineer, you can apply them, video games, fraud detection, various type of financial frauds, intelligent personal assistant, PA, virtual assistants, automatic self-driving cars, they are example of AI, email spam filters, AI in education, medical is again very big field where AI is being applied, research work is being going on, then mathematical problem solving and playing games like chess, and one more game we will discuss how AI is playing games where we have written here chess because chess is a game which needs human brain completely, no physical activity. You need your brain to calculate the next movement. So these are the a broader area of applications where a student can design projects, can develop some of the works, and work is going on. Now we are trying to understand how this AI is working. So one of the example, I will take one more. Here, in the normal programming, what happens? I brief you. Programmers write a program in any of the language. It may be Java, C, C++, any object-oriented programming. They know what is the data they are receiving. They know what calculation is to be done. And based on data and calculations, they write down programs and their outputs, which is approved by somebody else. But the programs does not know the changes or environment which is says what it is going, means everything is predefined. Now here in the AI, we are having a concept of environment and agent. Environment means surroundings which are changing minute by minute, day by day, or second by second. The change environment is changeable. Now your earlier programming is not capable to handle this environment. They are not understanding it. Now you are having here one agent. Agent is a complete body, mechanism, system, which is understanding all these changes in the environment. Environment means your surroundings where you are working and taking actions based on that one. For understanding these environments, you are having some sensors, and based on sensors, you receive the input data. Your internal program calculate it, and it decides what action is to be taken. So now important point is your program itself is understanding your circumstances around it. For example, if you talk about a self-driving car, a car which is running on a road, it need to identify its environment, which is running. Environment means car running in front of him, behind him, condition of the road, traffic on the road, the age you drive it and you see it. So that is like that one. So this is the major change in the field of intelligent program. So here we are having an example of agent. Agent can be viewed as agent can be anything that is perceiving its environment through sensors and acting upon that environment through actuators. So if you compare that in a human mind, we are having eyes, ears, and other organs to censor these, and we are having some actuators, body parts, mouth, legs, hands, for to take an actions. So we are trying, what we are trying to do now, programming. Programming is trying to do what a human is capable to do. We are trying to do that one. That is the starting point for your self-driving car. A robotic agent might have camera, infrared range, finders, and sensors for various motors and actuators. So here we are having intelligent agent. We are having three things: perceive sequence, and agent functions. What the agent is function is. We will take some more example on that one. Like take this is an agent. Now we take one more example of an vacuum cleaner. So vacuum cleaner. So there is a vacuum cleaner example, and we want to clean and vacuum, or we want to clean a space. So here your vacuum cleaner, coming example, it has some squares A and B. So now we have to see your robot on each has to check whether space is dirty or not dirty. It has some moves: move left, move right, suck up the dust, or do nothing. It has 4 defined functions. Means what we are trying to do in advance, you cannot program your robot. You have to suck the dust. First, it will have to check this environment, whether it is dirty or not dirty. Only then it has to suck the dust. It has to check there what is left hit, what is right of it, whether it can take move or cannot take move. So your robot has to take decision on the spot based on the environment which it is having. An environment is going on change minute by minute. Space for which we are making a robot and AI based application, we cannot tell him in advance if there will be this space is dirty, go and clean it. No, we cannot do that one. Your robot, you have left that place, robot has certain conditions, it will have to check environments, and based on the real time environment, it will decide on that particular moment what action is to be taken. So there is a major difference between the previous years of programming and right now programming which is coming in the face. So now see again this figure. This is your agent. It has some sensors. It's your environment. It perceives input, or you can say it takes some input from this environment, and based on this input it takes some action, and this goes on till we achieve our targets, till the work is completed. This is the meaning of this environment. Means, suppose we are talking about this uh, this is the example. Here it is a robot. This is in space which is dirty. So robot is going is this place and now checking it what is the conditions around it. And based on that condition, it is deciding what action it should be taken. Now, so the most important part here in the programming is agent. You can see like this diagram, agent. But in actual, this is a robot. This may be a program itself only, or it may be a system itself. So now we can say, understand that from this, what is an agent? If you try to understand the agent, agent is an architecture plus and program. So architecture barabar machinery that agent executes on it. So you can assume it is it may be a robot, it may be a robotic arm, it may be a moving car, it may be a self-driving anything, any four-wheeler for any purpose, any machinery which you can design for agriculture purpose, where it may be your drone machinery. So agent is an architecture and a program associated with it, and it works based on that. So I think this part is now you have clarity. Any doubt on this one? So here we are having, hello? Any doubt?
Yeah, yes, sir. Yes, sir. We are getting, sir. So carry on, sir. Carry on.
So now here you see this program. So in this program, when we are designing this thing A and B, we are seeing some dust there, a robotic arm there. So you have planned some simple move. A space is clean, move to the right, action. A space is dirty, start the suck operation. B clean, left, dirty, suck. A clean, right, and such. So you have defined 4, 5, 6 predefined operations to the machinery that in this situation you have to take this decision. Means the number of operations, number of decisions your machinery can take, you have designed in advance, you have programmed it and fit into your system. So in this way, this works. Moving further, so this clarify your agent work, and moving further regarding the agent. As a general rule, it is better to design performance measure according to what one actually wants in the environment rather than according to how one thinks an agent should behave. This is one of the important lines for the new programmers. It is writing that what is your performance measure? You have to focus on that one. Means you are designing a robot to clean a space, then you should write down your measurement or criteria on which you can say it has done work successfully. If you are designing a agriculture machinery which should go automatically and work something there, so you should define the parameters on which basis user is satisfied and the work, you can say work is done successfully. Not not on the second line, not rather than how one thing an agent should behave. You are not deciding how agent should behave this one, agent should behave this one, and he should think one. These are the secondary parts, programmer's part, which he will take care. Your task is the performance measure done by the machinery. This is the major part. So that's why where artificial intelligence comes into the picture. Now we take further some of the good examples where you can see that uh, AI works very well. These are the part of this one. Now we take an example of game playing, a very, very good examples, a game playing theory in the AI. So as we know, there are many games in the available. Some of the games are played with the mind, some of the games are played with the physical exercise. So now I take an example of a game, Deep Blue, that is a chess game. So now everybody knows that in the game of chess, your mind work, your physics does not require too much, only very limited works. So with the help of AI, in 1997, a program was developed on the concept of this one, and the game was organized against world champion. That was Gary Kasparov at that time. So you cannot say that human was weaker person. So computer means your AI-based program is playing or thinking against the known person in the world, which is the best player at that time. So now see how this happens, how this behaves. The Deep Blue was the name of this program. In 1996, it debuted the first Kasparov versus Deep Blue at this particular location. In 96, version of Deep Blue used a new chip designed by IBM for this purpose over the 3 years. So now see, your program is now here. Important point is this. In the here in this point, your important program is this. Your program is thinking about a move taken by the competitor. Competitor is well known, he is a well trained person. So your program is not designed previously. It is thinking based on the move taken by his opponent. As the opponent takes a move, after that, your algorithm written inside that one AI based algorithm program start thinking now what should he do it one. And surprisingly, on these matches, you will not get to know that in the first match they have played it in this match they have organized three series of this one. In the first match, Gary Kasparov won. After some training to the Deep Blue, 2 or 3 time training, computer was able to defeat the world champion Hello, screen visible? Hello.
No, sir. No, sir. No,
Yes,
sir.
please. No, wait just a minute.
Okay.
Screen is visible?
Okay,
Hello.
sir. Now it is visible, sir.
Okay, sound is coming.
Yes, coming, sir.
So now, dear students, now the first time the thing that we should know or understand that now your computer, inside computer we are having algorithm. Algorithm is learning from its own mistakes, which capability only human is having. So that is the role of AI. We need to understand. Before to that one, any of the program which you are writing, still right now in program writing in Java, C, C++, any of the object-oriented programming, programming is doing the task which programmer have set there. It is processing that data only. If one mistake is coming, it is goes on repeating many times. Your algorithm itself does not learn from the mistakes or from the errors. Only human understand and human can rectify this one. So point of learning is here that one. Now your algorithm itself is learning from its own mistakes, own faults, and improving itself just like an human, an intelligent human does, learning from its own mistakes and improving and coming to fight. Similarly, in another game, there was another game that is also known as Watson, a TV quiz show that you can imagine a quiz show like KBC in India, but this is example of USA, USA. So in this quiz show, if suddenly a question is asked to you, you cannot reply it very easily in a given time frame. Probability is very low. The probability is very low. If you are highly trained and having practice of that one, in that situation, you can compete it. Otherwise, you cannot compete. So now here again, IBM developed a computer name given in 2011, Watson computer, and it competed on a quiz show where real-time quizzing was going on. So the computer was able to defeat the current world champion of that particular event. It means your IBM Watson computer, based on the AI techniques and deep learning, it was able to give answers better than a human within a time frame. System learning from its own mistake, what mistake it has done, how it has lose the points, and improving further based on this AI. So this was another example. So this is based on the quiz based example. So IBM had developed this one. So there is one more example of AI where this AI is applied and it is defeating to again a human, that is a Go game player. Go game. It's very AlphaGo game developed by the Google. So AlphaGo is the first computer program to defeat human professional Go player, first to defeat a Go world champion and strongest Go player in the world. Means your computer is playing against the world champion of that Go player. So it means your this is a very old game. Now we coming to the played basically in the China, not in India, not popular in India, popular in the China. So in this game, you see some of the diagrams here. So in this diagram, you will be able to see that. Uh, See this diagram, AlphaGo. Now you are able to see this. This is a Go game where two are the players, black and white. They have to capture the opponents these stones and form some area where opponent is not able to take any move. So here, the important point is this: if this is a game comes by practice. The better you practice, better you will be understanding it. So AlphaGo, a game computer based on artificial intelligence, is able to defeat a human. How? The game itself was able to learn from the opponent's move, its own mistakes, learning from training, learning by playing. So, dear students, now you are having an era where program itself is behaving like a human mind, where it is getting trained by opponent's move, by own mistakes. So you see this game after 3 hours, AlphaGo plays like a human beginner and following long-term strategy to focus on greeting, capturing as many as stones possible. Within 3 hours, it was playing like a beginners. In 19 hours, AlphaGo Zero has learned the fundamentals of more advanced Go strategies such as length, and it was intermediately trained in 19 hours. Human cannot be trained in 19 hours. In 70 hours, AlphaGo Zero plays a superhuman level and game is described involved multiple challenges across the board. Only in 70 hours of training, in 3 days, it was playing like a superhuman level. And next you see the level of knowledge acquired by this is tremendously, and after just 21 days it was not possible to defeat him because he has captured, understand all the moves by the soft top professionals, and nobody can able to defeat him. So here human mind is working, computational is working, everything is working in favor of your program. So just 21 days working, your program was not able to defend human. So that is the power of artificial intelligence. On all AI is based on the machine learning. AI is the broader term, and it becomes like this one. So point is that you can develop the programs who can defeat the humans, who can understand from its own mistakes, who can improve themselves, and it is opening a new era of the complete programming. So now coming to the next part, I think this have cleared you that how powerful is the AI and the programming this one. Now I will focus on the AI traditional programming and this one. These are also required to understand for the engineers which are in the process to learn. In the traditional programming, what we are doing, we are giving some data. We are writing code in C, C++, Java, etc. And we are getting an output. Output is processing of this data. Output is your reports. Output of some calculations, like that one. All your banking applications are coming in this category. All your reservation system are in this category, and all big applications are database category. So they are successful across the global, and since last 30-40 years, all the programmers are doing that. But now for coming days, we are having machine learning and AI. It means the market for the new way of programming is opening for you. You will have to think slightly different from the traditional programming, which all are doing. Here, what we are giving data as well as output to the machine learning, and machine itself is having some new capabilities. Something like we have discussed earlier, it is able to check the environment also. It is able to take some actions based on runtime problems, runtime environments. It is able to improve itself. What the mistakes I have done, In the previous years, this capability was not there. If some error is going, then it will go many times. But now, your machine learning means your machine is learning that your previous program is giving this output as a wrong output. It needs improvement. So your machine itself having AI capability, machine learning capacity to improve itself and deliver output. So now when you will become an engineer, I would like to see you this in this category where you are able to design, write programs which are coming in this area, and industry required that one. Remember that one, industry expects from new engineers with the new knowledge, some additional knowledge which the existing they are all the programmers which are already employed, they do not have. You should have something, a different type of knowledge, different area of knowledge. So this is one of the field. So now we tell them in machine learning, machine is what? Data, information, and knowledge. Data is everything. You understand? It may be a text data, it may be and your numerical data. But right now, these days, picture, image is also a data, sound is also a data, sound is format. These two are also considered as data, and there are many applications based on the sound and image. These both are, these two things open in complete new scope for the new programming, new work for this one. Now, information, data that has been interpreted and manipulated and has now some meaningful interference to the information. Means raw data, you are having 100 images, that is your raw data. Out of 100 images, you have extracted that one. If this is meaningful for me, I am able to identify this person, that is your information. And knowledge is combination of inferred information, experience, learning insight, results in awareness, and concept building, some useful things. Means knowledge is something which is practicably applicable to an application. You can apply to somewhere, you can reach to an conclusion. So data is your raw data. You are having a person, you are having 1000 images, that is your raw data. Then from the raw data, you are extracting it, manipulating it, that will be some information. And from that, you are extracting some knowledge. So in these days, how we achieve this one? How we achieve this capability? This is one of the important data. So data in machine learning. In machine learning, we are having data. Means raw data. You are having 10,000 images. Say you are having images of all your friends, and faces of all. That is your raw data. So now we have training data, validation data, and testing data. So out of given images, we first train to the system, train our programs, give him training, just like when you go to the school, a small kid go to the school and initial days, and he doesn't identify anything. A school teacher or ma'am in primary nursery classes show him some apples. This is apple, this is banana. After 10-15 times, the particular child is able to identify this is apple, because he has seen it 10-15 times, 20 times. Some may take 20 times, some may take 10 times. So that is his training part. Means we are training a human mind. We are training a human mind by showing some physical article, giving his name, and showing him his features. These are the features of this one. Now I am showing 1 time, 2 time, 3 time, 4 time. Suppose you are going in an area first time, you are seeing some building first time. So some person will tell you the name, other features, this one. one time, two time, three time. After that, you will be able to remember that. So your training data in this complete AI training is important. We are telling to the system that this is very basic data and this have this capability. After giving data, we are validating it, whether it has correct or not, and then after we are testing it on some other data, whether system is understanding it or not able to understand it. It means, suppose there are various varieties of apples, various variety of bananas. I am giving training to the system that these are different varieties of bananas. After giving training, I am testing a new banana and testing it whether it is able to identify it or not identify. This complete process, when you understand it, you can understand it when you were child, started identifying some new objects, new things, new fruits, new things, you have adopted this process. And the computer industry is replicating that process in the form of data and in the form of softwares. So now we are giving training to the system. Earlier it used to be, now we will do in a little bit faster. So there are some machine learning algorithms, these are logical models, and your outputs. So how does machine learning work? Machine learning, you focus on the word learning. Earlier, learning was job of a human, but now it's work of machine also. A machine learning system learns from historical data, builds the prediction of models, whether it receives new data, predict the output for it. The accuracy of the predicted output depends upon the amount of data. A huge amount of data help to build better models which predict the better output. So training means we are just showing him data, giving him training, this is this one, and now you will decide it what is this one. So this training works very well for the images. We have applied it in some of our applications. It works very well and it understands it, applies well. So in the machine learning, you are having basically three types of learning: supervised learning, unsupervised, and reinforcement. These are the three broad classification. We will not go further. Supervised learning means just like we are giving training to the system in somebody's presence. When some supervisor is giving training to the system, okay, this is this one, this one, this one. Just like you go in the classes, your teachers come and it tells you everything. You are just learning it. You are getting training from your system, from your supervisor. So you can say supervised learning like this one. So somebody is giving training to the system. So that is supervised learning. There are some classification. Classification, it has two parts, categories: classification and regression. This is again from starting, it's very important. You can design many applications based on that one. You can design face identification based application, face detection based application, fruit detection applications based on the spam filtering, like that one. So that is the supervised learning. So now you can see supervised learning. There is a model. There are labels. Labels are having these names. Your supervisor told that this is square, this is triangle. Supervisor is telling that one. Now this is data. It is processing. And after processing, it is telling you this is a square, this is triangle out of this labeled data. Means earlier we are telling to the system that this shape in a simple manner, simple words. You are telling your computer that this type of shape is coming is a square. You are giving him training. This shape is a square. You are giving him 2, 3, 4, 10 times training. And now your algorithm is working, getting some images from many sources. As soon as this type of images come, it tells you this is a square. Just like that one, in a very simple way. You have told him, your computer, that this shape is a square label. When you are processing, many images are coming, it will tell from there that this is a square. Similarly, so this type of this is come in the supervised category. So next is we coming to the another major part, which is more applications. Now I will come to the this part of what is the advantage of this one. So you can design various fraud application. Fraud detection means this is applied in the banking system, financial system. They are having repeated patterns. Fraud detection, why? Because all the frauds, financial fraud, are done based on some repeated way of steps. They are repeating. They have invented one method to detect money and process. They will apply to some same process to another person. So that's why it's important there, and it is successfully applicable to there. So any question from your side? Any confusion?
Any queries?
Any queries? AI is a very vast field, and we are working on that one. Very new, growing, and one more thing that I will tell, this is easier compared to those students who are very afraid of object-oriented programming and have many confusion there that they cannot do programming. I will tell to them that please, AI is easier. Programming in AI and machine learning is relatively very easy, and you should not afraid of it. All the programs work with 10 lines, 15 lines, 20 lines. This is the only length right now required. Earlier days, programming used to be very large, 500 lines, 100 lines, 200 lines. But now, for the new engineers, it's a good thing that programming is getting shorter, very shorter. You can do programs within 20 lines, 15 lines, and AI is working in these 15 lines, 20 lines. So that is very good thing for all of you who are learning, and I hope that you will take interest in this and make your better career. Any question?
Yes, sir. I'm connecting with the students.
Yes.
So once I receive the question, I just pass on to you. Just, sir, wait for a 5 minute. Okay, sir. I think there is a no questions from the viewer side right
Okay.
now. Okay,
Okay.
so thank you so much, sir, to
Okay.
share us really wonderful knowledge regarding the artificial intelligence and machine learning. So, on behalf from the Parul Institute of Technology, computer department, I am also thanking you to give your valuable time and share a valuable knowledge. And behalf from the Parul University also, I am also
Okay.
thanking you for the same. To give
Okay.
us your precious time and really valuable knowledge to us and our students.
Hmm.
Thank you so much, sir.
Thank you. Just a minute, sir.
Thank you very much, Gupta sir.
Okay,
I'm
thank you so much.
head of computer department. Like I
Okay,
could not introduce you because of I'm having one like meeting.
okay,
Yeah,
okay.
we are very much thankful to you for
Nice
giving
to
us
see you,
time
sir. Nice to see
and
you. I
sharing
am.
knowledge with our
Uh,
students.
thank you
Thank
very
you
much
very
for
much, sir.
inviting you. Thank you very much for inviting me. I am available, and you can take my services. Any of the related fields. I have a vast experience in the programming and teaching also. So thank you once again for.
Thank you, sir.
Thank you everybody.
Thank you so much, sir. Have a good day.
Have a
Thank
good
you,
Okay.
sir.
Among sir, now like just stop the recording. I think
Yes, sir. Yes, sir.
I'm leaving now, huh?
Yes, sir.
Okay.